So to our speakers, what I'd like to do now is hand over to Philip, and he's going to take you through the next 20, 30 minutes to cover what his experiences are from being originally, it sounds like a technical background, and now running a very prestigious organization over in Silicon Valley. Over to you, Philip.
Alrighty. Well, today's talk was actually going to be a live talk on or about this time, but we decided to travel virtually. And the title of my talk is Don't Become Irrelevant. And I think that AI is definitely one of the topics that's very, very on the top of people's minds besides the virus. And one of the things I thought about was the old cliche was working smarter, not harder. But I think we need to do more than that today. And that includes grasping new technologies and thinking about totally different ways of doing things. And AI is part of that. A little bit about myself. I founded a company called XBOsoft over 10 years ago. And the only thing we do is software QA, consulting and testing, which you might find interesting more than my professional background, which you can find on LinkedIn, is that I love cycling and travel. And you can see from my background that there's a desert background there, and that's from Death Valley. I was just there a few weeks ago before the whole stay and shelter in place order came about in San Francisco. So now I'm here stuck in San Francisco, a really bad place to be, but I'm glad to be here today. So let's talk about how we got here in terms of to this AI world and paradigm that we live in. It started, say, 50, 60, 70 years ago with the advent of the mainframe. Actually, AI algorithms was already invented at that time, but it wasn't really able to be realized because AI is so data intensive and processing intensive. Then we had, of course, the advent of the IBM personal computer back in the 80s. And then telecommunications went digital via fiber, which enabled us to move data around. So that's the first step in AI, is being able to move that data around very quickly. Then we had things like mobile phones, and in particular the iPhone, which came out in 2007, which began to start creating that data. All kinds of data, as you know, are collected on the mobile phone and captured via a plethora of sensors on the phone. So we have a bunch of data, and then we started having all kinds of IoT devices, including the wearables and different types of things that, through the use of Bluetooth, are able to capture and transmit data and collect it via the cloud. So then we have another technology which was brought about by increases in computing power, along with cheaper methods for storage, which brought about usage of the cloud. They all kind of came together, and now we have AI, which uses that data and processes it. And with the recent advances in quantum computing, I see there's just going to be a huge momentum going forward with AI. And that includes for us in software testing. Just a little bit of background about AI. When I first started looking into AI, I asked a friend of mine, do you guys use AI or ML in your development process and software testing? And he said, well, you must not know anything about AI or ML, because all you need to say is, do you use AI? Because ML is a subset of AI. And I thought, oh, okay, I guess I better start learning a little bit more about this stuff. And so this slide here just kind of gives a snapshot of what machine learning and deep learning are relevant to AI, in terms of AI actually behaving and thinking like humans, getting machines to do that, and ML training machines to improve and learn on their own with more data. And then, of course, you see the deep learning, which is using neural networks and different ways of learning to increase the intelligence of AI. And I started to think, okay, so what is the difference here? And when I looked on Google, I found that machine learning is actually more popular and more demanded in terms of what people are searching for. And I thought this was interesting. So I thought, okay, well, let me look more into machine learning and what that really entails and how that can affect and improve the development process. I also looked at, of course, the Gartner hype cycle, trying to figure out what people are doing, how this applies to us as software geeks. And you can see that the automated ML, machine learning, natural language processing, those things are either at the top of the hype cycle or starting to go through what they call the trough of disillusionment. You see that things like data labeling, which is the categorization of data and figuring out what data is all about, is on the upswing. And that's one of the big, I would say, one of the bottlenecks of AI is getting that data and understanding the data. Because just like the old saying, garbage in, garbage out, if you don't have good data and have clean data and meaningful data, then it doesn't really mean a whole lot for AI. Of course, you see computer vision, and computer vision is one of the big things for test automation in terms of recognizing objects. And you'll see that we're getting close to the trough of disillusionment. So this is going to be really interesting going forward. I know some of the other speakers are from different backgrounds that actually make tools which do test automation. And I think a lot of the test automation work for some of these tools is about recognizing objects. We did do some trials in working with different software, and we did find that there was a weakness in recognizing, not only recognizing the objects, but learning how to recognize objects and teaching the algorithms to recognize objects correctly in a consistent basis. So what I'm going to talk about today is some of the problems in software development and testing that we have. And then next, talk a little bit about AI and how they can apply to those problems. And lastly, I'll talk about what I call the silver lining, which is opportunities for today and tomorrow, given the situations that we have currently. Like I said, working smarter, not harder is not enough. And we need to get better at building quality software. And so when I think about it, I think, so how do I break down the software quality and software testing process? And I think that any of these areas are ripe for using AI and adding intelligence to software testing. So, how do we determine where to test in terms of test planning? Well, you can use AI to analyze data to look at where should we be testing. The same thing with designing our tests. What kinds of tests do better than others in terms of identifying problems? And then looking at test results, analyzing those test results to figure out where we can get the most bang for our buck in the testing. You can see that our test coverage has a dimensional explosion. If you look at how we generate tests, well, we can add more people, we can add more automated tests, we can add more people that add automated tests, but that again is linear, right? So you can only add so many people, you only have so many hours in the day. And so our goal and what those that are using AI and their tools are trying to get around and get up in front of this explosion. And it's really not just exponential explosion, but really an explosion of the nature of the power function, which increases the exponent, 10 to 20 times. The question is, how fast can you generate tests, and how fast can you generate good tests, whatever those are, right? Another problem we have is that we just don't have enough people. We don't have enough skilled people with the right skills, and sometimes learning how to do testing or learning how to do automation is a problem. Not only that, working together, personalities, attitudes, etc., those contribute to some of our demise in developing quality software. Writing code, writing tests, it's a hard thing to do. Like I said earlier, you have to be properly trained. Sometimes they can be difficult. And We all make mistakes. Maintenance and scale. So, you've all heard about test automation code. It has to be maintainable in terms of not only recognizing the objects from the get-go, but also being able to adapt to objects that change names or change shapes or change locations. And who has the time to do that stuff? Now, I put this picture of a lawnmower here because I would bet that less than half of the folks on the call today, on the webinar today, mow their own lawn. Because why would you want to mow your own lawn? We just want to get somebody else to do that. It's dirty. It's something you don't want to do. You got to have special equipment. A lot of people just don't do it anymore. That includes cleaning your house and so on. And so I think that maintaining automation code is very much along the lines of mowing your lawn. It's just something that you just don't want to do, and who has time to do it? So you want automation code that can maintain and fix itself, right? Another problem with computer vision and what object recognition is, like I was saying, that these objects can change locations, they can change names, they can change a little bit of their functionality, some of their attributes can change. So being able to recognize the objects via more than one attribute is really, really important. And being able to understand when attributes change doesn't necessarily mean that the function of the button changed. So that's really important for us to be able to figure out with AI as well. So here's just a little bit about where AI is used today. As we all know, facial recognition, autonomous driving, things like that. And this is a slide borrowed from Diani, one of my colleagues, where he mapped this out in terms of being able to get training data into a machine learning algorithm. Then you use that and develop a model and implement that algorithm. You do some predictions and evaluate whether or not you were able to do a good job. Evaluation could be yes or no, yes, I was right, or I was wrong, and I'll go over that soon in terms of looking at the different types of machine learning. And then, of course, recognizing that input data and training data is one of the critical elements of a successful machine learning algorithm. So here's just a kind of a synopsis of machine learning defined. I call it AI 101 in terms of getting a machine to learn without being programmed. That's hard to do. And so the way it was defined by Tom Mitchell about 20 years ago is a computer program is said to learn from experience E with respect to a task T and some performance measure. If its performance on T as measured by P improves with experience. Now, this is kind of hard to understand on a conceptual basis, but if you put it in real terms and you think about it like this, if your email program looking at spam watches emails you do or do not mark as spam, and based on that learns how to do better filtering, then you can kind of phrase that in terms of what is T, what is E, and what is P in terms of the performance measure. And so the experience is E watches emails that you do or do not mark as spam, and then your mark as spam, that would be the measure of performance, spam or not spam. And then the filtering of the email is actually the actual task that the machine is trying to do. Going on with our short machine learning primer, when I was learning about AI, I said, okay, well, let me try to understand how this works because I want to be able to apply it intelligently to testing. And you can see that there's two types of machine learning, supervised and unsupervised, and there's further classifications of these types of learning as well, and I'm going to talk about these in a second. So the first type is supervised learning, and this example comes from Coursera. Supervised learning would be something like you take housing prices and you look at the size of the houses and the price that they sold for, and you can do a regression in terms of learning what the price should be based on past data. So if I have a house that I'm about ready to sell and it's 119 square meters, and then it should be approximately, say, $210,000, $2,000. That's called regression. It's called supervised learning. So based on this learning data set that you would put into your ML algorithm, it could come out with some type of predicted price on a graduated scale, right? And so eventually you would predict the price, and then you would have the real price, and it would start to learn, okay, based on this factor, it's too high or too low, right? And you get a continuously valued output, the price, that has increments, very, very small increments, right? You can see that on the scale here. You have whether it be 122 meters or 144 meters, you can still get an output. On the other hand, we have supervised learning. Supervised learning is about classification. And so you can see here that, for instance, you have tumor sizes and determining whether or not predicting, right? We're trying to predict here, use machine learning to predict whether or not a tumor is malignant or not. And you can see that, well, okay, if the tumor is small and I'm putting in these data points, okay, it was not malignant, it was benign. And then if the tumor has a certain size range, well, then more than likely it's going to be malignant. And so you have these inputs of sizes and then outputs and of real data in terms of malignant or not, and you can develop a prediction algorithm to determine whether or not the tumor is malignant. That's called classifying, right? So it's malignant or benign, yes or no. It also is not limited to 0 or 1, yes or no, but could be a discrete valued output anywhere, you know, as long as it's discrete values that you have as an output or a possible result. Transforming this down to putting it all on one line, you can see I put all this data on one line at the bottom. This gets us to our next type of machine learning, which is about classifying in a different way. So you take groups of data and you classify it in terms of tumor size and maybe add another categorization or characteristics such as age, and then you can kind of add more characteristics into your data set, right? And then you can say, okay, well, what other data attributes or characteristics of these tumors should I consider? Well, I could consider the cell size, cell shape, the hardness of the tumor, many other characteristics that I can think about. And you can see how this two-dimensional matrix or two-dimensional graph here could become many dimensions, and therefore you would need some type of machine or algorithm to process that. So let's do a little quiz here. If we want to examine all priority 1 defects and predict how many will get fixed before the next release, what kind of a problem would you think that would be? Would that be a classification issue that you could use machine learning for, or would it be regression, right? And the same thing for if I wanted to examine each defect and decide if it is priority 1 or priority 2, would that be a classification problem or a regression problem? And so now you can kind of start to see where these machine learning concepts can be transported into our daily work as software quality folks. So let's look at supervised learning now, or unsupervised. And unsupervised learning is really all about clustering, pattern recognition, making some kind of sense. Oh, we got making some kind of sense about the data. So, getting to object recognition. What type of machine learning of object recognition is object recognition? Well, obviously it's a classification issue, right? It's a classification issue with many different discrete level outputs. Let me see if I can, there seems to be a beeping here. Looks like there's a chat. Let me see if I can, okay, I don't understand the distinction between classification and regression here. Well, okay, maybe we can get to that later, I hope. Okay, so maybe I can explain this here. So in other words, if I'm doing a object recognition of these objects, it's either a mouse or it's a handbag. It's not something in between, which would be regression, which would be half handbag and half mouse. So, and the same thing with a tumor, it's either benign or it's not. Whereas the housing price, when I put in a bunch of inputs, it could be, it's not 240,000 or 300,000, it could be anywhere in between. And that would be a regression. Hope that it clears that up. Let's see here. Okay. I think I'm going to skip over the slide, but this is really the same thing where you apply AI principles of software testing. You have a bunch of inputs, you put them through some type of models and training and development. And inputs are data, basically. Data such as what type of test it is, what function you're testing, whether it was passed or failed, the past information on the actual test case, and so on. And then you get an actual versus expected result. So anyone could talk about AI, but what about QA and testing? What problems can we solve? I've gone over some of the issues in terms of prediction. Test automation, we can certainly get a lot better and faster and reduce the maintenance effort. But the real question to me is, since I run a software testing organization, is how can we increase our defect detection and reduce defects in production for our clients? And of course, the bottom line is the software ready for release, right? Is the software ready for release? That could be a regression problem. When I think about it, it could be the probability that it's ready for release is definitely a regression. It ranges on a scale, right, from 0 to 100%. Or I could consider it a classification problem where it's 0, not ready, or 1, ready. So the problem about applying, and I'm going to go through some of the issues in applying test automation, AI to test automation. The problem is that it's labor intensive. Finding and discerning objects is an issue. Changing the attributes. And of course, recognizing and teaching the algorithm to learn is it's not exactly that easy. I mentioned earlier that we tried on a couple of different products and we had difficulty in the accuracy, but more important than the initial accuracy is training the algorithms to get better. Test generation, there's the problem of collecting real good user information to actually generate the test because you want to simulate a real user, right? So that's definitely an issue in aggregating user flows and creating these test cases. Machines learning from humans. So you could have a machine mimic or try to think like us as software testers, getting information from us, but observing what we're doing, getting the input, having a test oracle, and also making your algorithm more generic rather than specific to a certain application or page can be difficult. Here's some of the things that AI can do in terms of writing better code. This is a video from a large internet company in China. And you can see that what they do here is they're actually using autofill to help their developers make better code, analyzing each developer's mistakes that they've made in the past and helping them to autofill and complete their code in a better way. Is another one where they actually develop developer profiles. The profiles of a developer could be the errors that they've made or the bugs that they've found that are related to that developer, and analyzing those defects for that developer and being able to help that developer to make better code. Other ML applications, like I said, was in prediction, focusing on where to analyzing defects as input and being able to predict where defects will occur and so on. So what type of machine learning algorithm can we use for these things? I think you could probably figure that out from today. But wait, there are some issues with machine learning and artificial intelligence in terms of analyzing the data. And so let's take a closer look at that right now. So we have a lot of natural ways of thinking about data. And I put this tiger up here because naturally, we as human beings, if we hear something in the bushes, we might naturally run, right? And so AI is supposed to help us get over these natural intuitions that we have and say, okay, well, let's take a bunch of other inputs besides noise in the bushes, and maybe it's not a tiger, right? And so taking all this other input in, will help us to get over the biases, and hopefully AI is supposed to help us with this. There are a lot of cognitive biases that we have. I won't go over them. I just thought about one the other day. I was washing some clothes in terms of anchoring. You know, when you fill up the little cup for laundry detergent and it has a line on it, they have actually anchored us into thinking that we need this much detergent, but maybe we don't. So I started doing some experiments, putting in a little bit less or a little bit less and seeing how much really do I need to get it clean? But they've anchored us to think that we need a whole cup of detergent. Well, I don't think we really do. So there's a lot of these different biases that we have. And the thing is, AI can help us with these. Here is a list of biases. I'm not going to go over them, but you can use this later and use it later for reference. You'll have copies of the video. I talked about machine learning issues, one of them being classification and spam or not spam, right? And so deepfakes is one of the areas that that people are working on Google in terms of getting in a data set. Is this real or is it fake, right? And so there's different types of characteristics. You can see that's a classification issue. What are the attributes that they would feed in to determine whether it's fake or not fake? You can see that multi-dimensional matrix in terms of the characteristics of the data to determine fake or not fake. Is this supervised or unsupervised? I'll let you guys answer that. Another one, everybody's seen this, where they have problems with facial recognition and misclassifying a photo as a gorilla because of the dark skin. And so the same thing with autonomous driving. I start thinking about, okay, so what kind of data is needed to make the data set complete and dependable to avoid crashes? Lastly, there's the issue of silent data. You know, this is taken from some research I did on turkeys. You can see that they need 4 to 5 months to grow to full size, 16 weeks to get to 7 kgs in weight. That's really fast. And all along this time, the turkey is eating every day, having a great life. Little does he know that suddenly he will turn into Thanksgiving dinner. And so the question is, what can we learn from the turkey? Well, the turkey obviously doesn't have the data that soon he will be eaten, right? And so the thing is, just because you don't know doesn't mean it doesn't exist. And so I got this thinking from Nassim Taleb's book on the black swan. Really, really interesting book on the concept of data that is silent, and that the proof of burden of proof, where does that lie in terms of whether or not it exists or not? And that really gets to the heart of AI. The heart of AI is in the data, and we have to be really thoughtful and careful about taking the inputs of data, like I said before, garbage in, garbage out. And so now I think you can think about, you have enough background to think about the different types of machine learning and how you can trick AI, I think. And I'm going to get to today and think about, okay, so we know the weaknesses of AI and machine learning. We know what it can do. It's scary out there, right? Here we are today with COVID-19. You can see from my profile shot versus today, I can't even get my hair cut, so I put my hat on because I can't get a haircut. What does it mean for us software nerds? So one thing I thought about is that the world has really shrunk. Our leaders are really preparing for the wars of yesterday. And so viruses, they can jump over walls fairly easily. Tanks have no effect on viruses. And here we are, shelter in place, like I said, no haircuts either. And so because the world has shrunk, other countries, what we thought was their problem is now our problem. It's a world problem. I think there are a lot of world problems today that we try to tackle or not tackle as a country, which is definitely the wrong way to go. So we have the old world, right? We as businesses and humans want to come together. And you think of all these industries and all these things that are dependent on us coming together. Andrew mentioned earlier about, oh, we're going to return to physical meetings and so on, and our next meeting and so on. And, you know, I'm not really sure about that. How much will that return? It depends on how long this goes for and how long it can actually change our paradigms and our ways of thinking. You think about all these different avenues that depend on people getting together. The NBA season was all canceled, right? Conferences are canceled. Gyms are canceled. Everything is closed. And so I think about, okay, the new world, post-corona, the new normal. I think that viruses are the weapons of tomorrow, both biological and in terms of computer and network security. Driving for automation, robots, they don't get sick. So I'm sure that Amazon is working even harder now towards automating their warehouses. And there's this whole thing about working at home, or WFH, working at home, working from home. And I think that especially the working from home is going to change big shifts in the way we work. And of course, there's collateral damage. I'm looking at my retirement fund, which used to be what's called a 401k, and now it's a 201k, right? So elderly folks, people that are thinking about retiring soon, they're going to have to rethink that. Many things that are going to be damaged because of the situation that we're in today. But here are some bright spots. So you think about the drive for automation, working at home. What's going to happen? Okay, so we're going to have a lot of opportunities in remote healthcare, a lot of opportunities in no physical banks, having a cashless society, moving more towards mobile payment. What kinds of software opportunities are those going to create for us? And the same thing with education. I think people are going to discover, well, I can get an education without sending myself or my son or daughter physically to a college. How can I do that? And the whole, what I consider the office infrastructure reset. Let me see here. Yeah, I'm almost done, Andrew. Almost done. And so so a lot of these opportunities here, and it's going to create an increase in demand on software. We're going to have a lot of new business models, a lot of new software opportunities, and all of these things are going to be built in with AI into the business model and into the future. And so I think our crisis has a silver lining. I encourage you to learn as much as you can, not only from today, but continue develop a learning plan on what you're going to learn today and tomorrow to prevent yourself from becoming irrelevant. And here's an open source libraries for reference, which you can have later. Here are some reference lists and learnings and folks that I've learned from and asked lots of questions. My dad used to say to me, don't ask so many questions, it's because I said so. Well, I think you should still ask lots of questions. So that's all I have for today. Don't become irrelevant, and I hope that you're ready for the new world.